4.0, or the fourth industrial revolution, is the current trend of automation and data exchange in manufacturing technologies. Industry 4.0 fosters what the industry has been calling a smart factory. These modular structured smart factories and cyber-physical systems monitor physical processes to create a virtual copy of the physical world and make decentralized decisions for material, logistic, production quality, fine-tuning, and equipment management. ASMPT, together with its customers and partners, are creating smart manufacturing solutions that are focused on 7 key technologies to create Industry 4.0 solutions. Predictive maintenance is an essential feature in a smart factory. With this function, machines can perform automated introspections and alert the operator before physical errors occur. Our global R&D teams are working on this key aspect in various technological domains to target 95% detection of motor defects, 80% of mechanical defects, 70% of electronic defects. This capability can significantly improve machine utilization, production planning, and equipment lifetime management. Digital twin is a virtual form of a product and its process. By simulating the mechanical structure and the digital information from the actual machine, digital twin can run risk-free virtual trials and tests. The virtual production process can be monitored and analyzed to improve its performance and efficiency before being physically deployed. Digital twin is an essential feature that benefits an effective and reliable manufacturing process. Robots are crucial to the automation lifecycle of the future factory. Robots are armed with ASM's vision system, together with smart sensing, artificial intelligence, and fine force control, can further improve the way we are producing beyond just providing uninterrupted material supply to the equipment. Collaborating with these smart robots will allow manufacturing plants to be more productive, reliable, and flexible on the factory floor. Data-driven process and quality optimization is a focus point right now. Our plan is to create an expert system based on our own automated inspection and measurement machines to quantify production quality. The purpose is to optimize processing performance and minimize defects during production. Quality inspection data and machine parameters will then be automatically analyzed by our smart data analytics tool, Deep Data, a very friendly one-click model-out data analytics tool to get the best performance. Process visualization technology allows users to closely monitor the status of large amounts of production machines, materials, and performances on a single dashboard. It also allows for remote controlling through mobile devices, such as smartphones and smartwatches, to track production quality problems or mission production targets. By using mobile technology, production efficiency is greatly enhanced and error recovery time shortened. Manufacturing Executive System, or MES, is a vital software system that communicates with the manufacturing host and production equipment. It executes production plans, collects data, gives real-time feedback, and reports manufacturing statuses. MES will optimize the throughput by intelligent algorithms. Our team is working closely with our software arm, Critical Manufacturing, to create more efficient factory floors for our customers. A smart factory is connected in terms of material and data. Production machines, measurement equipment, and automation systems are all digitally connected to share real-time production data so as to fully utilize the production capacity and performance analysis. Our teams are developing an automation system for material towers and mobile robots to automatically transport and feed production materials to machines. This way, the machines can continue running without having to stop and wait for materials.
These 7 technologies are the cornerstone of building a smart factory. Smart factory is reshaping the future of our industry. This initiative is to integrate all the machines, automation, controller, and data together to discover new information and identify opportunities to take corrective or optimized actions automatically with the help of artificial intelligence, data analytics, and MES. Of course, there are some challenges. One example is the transition of our equipment from traditional hardware-based to smart equipment, ready for integration and flexibility demanded by smart factory, which is the digitization of the machine to capture and share data. The other challenge is the smart factory concept, demanding vertical and horizontal connectivity, AI and data analytics for analysis and improvement. In order to make science user-friendly, we are developing the tools of deep data and AI platform, such that each of us can use it. It is an exciting new avenue of learning and creating value for customers. How will we achieve it? We have passionate R&D staff from different sites working on it, and we will definitely make it happen.
Yes!
Thank you, Mr. Wong. In our next video, Mr. Stanley Sui, Executive VP of the Group and CEO of Materials Business Segment, will be discussing how we are transforming and equipping ourselves to create a smart factory. See you then.